Good afternoon, everybody. My name is Gareth Heywood. I'm with Semtech Corporation here on the SDVoE booth. And today I'm going to give you a quick update about the IP standards that are used in live production in broadcast. And obviously you hear a lot of overlap between that and the Pro AV industry and what's going on with IP in general for live production. So what's the status of SMPTE 2110? Well, if you go to any of the broadcast shows and talk to the manufacturers there, you'll know that 2110 has come of age. There's a bunch of ratified standards now available through SMPTE that are designed to take uncompressed AV transport and send that over Ethernet, and that could be anything from 10 gigabit Ethernet up to 100 or even 400 gig depending on your requirements. There's standards there used for seamless switching, which is very important to the broadcast industry, probably not so important to us here in Pro AV. In broadcast, when we talk about seamless switching, they actually are sending two identical feeds over two separate Ethernet links, just in case one of them fails, and if it does fail, it seamlessly switches over to the other stream. They're continuing to evolve the suite of standards that are available within SMPTE. They're adding things there to handle compressed video, traffic shaping, lots of other things going on in the background. However, SMPTE 2110 is really only half the story. Even though it's a standard, it's really just telling you how to get your bits essentially onto the network, and that's about it. How do you get your bits on the network, how to do them correctly? But in order to make a SMPTE 2110 system that's useful and user-friendly, then you have to go to the AMWA NMOS specifications, where they define things like connection management. And the two key documents that have been published with AMWA are ISO 4, which is discovery and registration, and ISO 5, which is connection management. On top of that, you've also got this joint task force on network media. So this was formed by a bunch of organizations, including AMWA, but also the EBU, SMPTE, and the Video Services Forum. And the idea behind this is to come up with a technical recommendation to address specific user requirements. So essentially, a way to take 2110, the NMOS specifications, and somehow make them useful to you in your end application. And again, what they're doing in this industry is very much focused on the needs of broadcast. So all these standards and protocols are engineered towards broadcast workflows, i.e. how to get a camera that's live on air to a production switcher that then can produce the actual show that's being filmed. As part of this joint network task force, they've published what they call the EBU Media Node Maturity Checklist. And this is really interesting. Just take a second to look at this. We've got a color coding here. Green means it's widely available, or if you want to say it, that's the most commonly adopted pieces of the puzzle that's been implemented in equipment manufacturers out there. And of course, as we go down the pyramid, we see certain things are partially available and certain things are readily available. So they've done a lot of testing within the EBU. They conducted a very, very lengthy plug fest. I think there was hundreds of participants, and it was really there to determine the maturity of SMPTE 2110 and the NMOS specifications. And they looked across three different things mainly. So it was the top three here: media transport, which is 2110, timing and sync, which is SMPTE 2059, that's the PTP timing standard. And then 3, discovery and connection. So that's how the devices actually know they exist and can actually start transferring flows between them. Because obviously you can plug stuff into a network and it won't go anywhere unless somebody wants it. And that person that wants it has to know that that stream's on the network in the first place. So if you look at this pyramid, it really speaks for itself. You can see that the media transport piece, i.e. the 2110 piece, no problem. Engineers have figured out how to get the bits and bytes onto the network. Great. Timing and sync, it's in the yellow. That means it's inconsistent across users. That means that some guys can get video to their equipment on time and be able to recreate that image correctly. Others not so much. And then this one discovery and connection. I personally think this is the most important. Within the SDVoE Alliance, we see plug and play as one of the key advantages of our technology. The fact that you can take a box from manufacturer A and plug it into manufacturer B, and they will start talking to each other, is key. We all expect that from our home use environment, right? We expect things to just work. But plug and play is really impossible without 3. So already down the pyramid, we're struggling to find manufacturers that have actually got plug and play working. If we then compare this to the stack, the SDVoE stack, which is on your right, we provide a full stack solution. So up to layer 4, it's basically standard Ethernet protocols. So you've got everything right up to the transport layer there. After that, you get into the session management and the clock recovery. And on top of that sits our API, which is doing all the network discovery, the control, the setup, configuration, making sure flows get from one piece of equipment to another, and even doing things like cropping and scaling pictures. We have commands for that. So we've got a fully baked stack from top to bottom. If we were trying to do the same thing, but going down what they call the standards route, we'd have to go to several different organizations to get all the information we need. To get us up to layer 4, we would go to SMPTE. So 2110 and its suite of standards plus SMPTE 2059 PTP gets us up to layer 4. It gets everything working fine up to that point. But beyond layer 4, you have to go to a different organization, as I already mentioned, AMWA. And within AMWA, you've then got to take a look at the NMOS open specifications. When you start to dig deep into all these standards, you realize there are certain influences from other organizations. For example, AES wants AES 67 to be the audio stream of choice when implementing 2110. However, when you look at this AES 67 model that's used in 2110, it's a constrained set of AES 67. It's not AES 67 as is. Similarly, you've got organizations like AIMS who are trying to shape the way you use these standards to make them work in specific flows, as I said earlier, so specific broadcast workflows. So it's not just a simple case of buying, for example, a chip, which would do all of this for you, and running some software that sits on top of that. It's a case of having to sift through a whole lot of organizations and standards, piece them together to make them work for you, and then hoping that you can have an engineering team that has to write all the code to do that and run on probably a fairly significantly powerful FPGA. I talked about the influence of AIMS, and you saw that there's a Pro AV working group now within AIMS. This was launched in December 2018. They published a paper in May 2019. And these guys have come together to promote media over IP protocols that are dedicated to the professional AV and install market. And the most participants aim to basically recoup their investments they've made in broadcast products. So you saw on those other slides all that effort that's gone into making 2110 work has not paid off. Basically, the broadcast market isn't big enough to sustain the investment that you've put in to make your 2110 products. So now they're looking to other markets to try and recoup that investment. And obviously Pro AV being probably about anywhere between, depending on who you ask, it's about 5 times to 10 times the size of the broadcast market in terms of number of products sold. Often when you go, like if you go to the AIMS booths in various trade shows, it can be kind of confusing and misleading. A lot of the stuff they're showing on there and a lot of the demos is broadcast equipment. It's not really relevant to the sort of things we're doing, for example, on this booth where we're showing video walls, multi-viewers, matrix switching, but using standard networking technology. And many of the presentations are done by broadcast manufacturers, and they really have no relevance to Pro AV. This slide is now a little bit old. You probably saw there was an announcement of the IPMX standard that was coming out of AIMS, or the recommendation. But we've yet to see a fully demonstrated set of requirements to date that's been employed by multiple manufacturers, all interoperating with each other. I just want to give a shout out to Network NDI. This is another solution that's on the market today. NDI is a high performance standard. It allows real-time, ultra-low latency video on existing IP video networks. NewTek was acquired by a fairly significant broadcast production equipment company, Vizzert, to augment their virtual production tools. It's typically used in bandwidth-constrained type environments, for example, over 1 gig. And it obviously uses things like standard compression tools, such as H.264 for HD and HVAC for, should be HEVC for 4K. It uses an open platform allowing software implementation, so there's not a lot of hardware required to do an NDI type solution, and they have an SDK and a comprehensive set of tools to allow you to create your own plugins. However, as I said, a bit like 2110, they're very much focused on certain workflows for things like live and offline video production, so not really focusing 100% on all the needs of Pro AV. It's more for things like webcasting, Skype, GoToMeeting, and Zoom, those kind of applications where you want to do sort of a more professional kind of production. So all this is to say that the broadcast industry and its various alliances remain focused on live production workflows, not the requirements of the Pro AV industry. Current ST2110 based systems provide partial interoperability, with even discovery and control only partially implemented. As I showed you in that pyramid, there's a lot of gaps in things like setup and control. There's been little progress in AIMS with their working group. We saw some news ahead of this show, but that's pretty much it in just over 18 months. As I said, NDI is focused on video production tools. There's minimal overlap with Pro AV and the kind of applications that SDVoE is focused on, which is matrix switch replacement, video walls, multi-viewers, that kind of thing. And to summarize, SDVoE remains the only interoperable full-stack solution that's been uniquely developed to serve the Pro AV industry. Any questions? All makes sense. All right, carry on.